Our next type of problem is the heat of fusion or vaporization. Both of these are dealing with B or D. Okay, so notice that we couldn't use Q equals mc delta T that we used for A, C, and E because there is no delta T. And if I put in a 0, my answer is going to be 0. And obviously, we have to put heat in to melt ice, or we have to put heat in to boil water. So the question that we need to answer is how much heat is needed to change a solid to a liquid or a liquid to a gas? Well, there's two things that the heat depends on. It depends on how much substance we have, because it's going to take a lot more heat to melt an iceberg versus melting an ice cube. And then the actual substance itself. It depends on what that substance's heat capacity is. And so if it doesn't take a lot of energy to change the temperature of that substance, then it won't be as much as something that has a higher heat of fusion or heat of vaporization. Those are constants, and those constants will be provided for you. They're not anything that you need to memorize. Here's our equation. Q is equal to M, which is our mass, and delta H, H is enthalpy, but we use that symbol to mean our heat of fusion or our heat of vaporization. Q equals heat, M equals mass, and then, like I said, delta H is the heat of fusion or the heat of vaporization. There's no temperature change in these problems. So that's one of your signals. When I ask you to solve for how much heat does it take and there's no temperature change and you're stuck, this is what you need to think about. Oh, there's another equation that's actually even a little bit easier. Okay? The constants, the heat of fusion, and this is for water in particular. Okay? So this would be, both of these are water. But this would be ice, and this would be boiling. So this goes with this B, refers to this B here, and this D refers to this D here. Okay, so that at this point it's 340 joules per gram, and here it's 2260 joules per gram. So when we solve a problem, how much heat is needed to melt 25 grams of ice? Well, we're going to use our equation. Q is equal to the mass times the enthalpy of fusion. There's no change in temperature. We're just looking at the melting part. So it's 25 grams times the 340 joules per gram, and we end up with 8,500 joules. Okay? Again, these problems are very simple, but when they're all mixed together, it's making sure that you can recognize which problem you're solving for. Heat of vaporization works the same way. How much heat is needed to evaporate 25 grams of water? Same equation, and sometimes you do put this vaporization or the FUS for fusion. You'll see that to denote which is which. 25 grams times the 2260 joules per gram, and we get 56,500 joules. So again, another simple type of problem, but I want you to start looking, once these are all mixed up, it's recognizing how to solve them that makes them a little more difficult. And so I'm trying to point out to you some of these differences.